I'll be honest, this is not the way I like to teach derivatives, but I don't want to teach limits until you get there in your AP class, okay? And when you get there in your AP class, then I'm going to show you why these rules work. One of the problems with limits is it's just a way of thinking. A function is what's happening at a point. A limit's what happens as you get close to it. And this calculus and all these formulas are based on limits. And you're going to learn about limits in your AP class. And when you do, I will go back and I'll show you why these formulas work. I won't do all of them, but I'll do enough that you see the process. The catch is, if you don't know limits, I can show you how lots and lots of calculus works as far as getting to the solution and getting results. But as soon as you ask, why does it work, I need a limit to explain why. And I'm skipping that part today because I don't want to, okay, when he teaches it there, I'll go back and dabble in it, but I'm going to let him do limits before I ever deal with them in here. Fair enough? So this is Chump Trig derivative lesson. Works, but we're not going to talk about why it works. And here you go. The formula says the derivative of the sine of u, which is some function. Instead of f, we're going to use u because it fits in all the calculus stuff of the future. The derivative of sine u is equal to cosine u and then the derivative of whatever the u is. That du means the derivative of whatever the u is. Fair enough? Okay? That's our first formula. Well, it makes this problem really easy to work. If you wanted to know the slopes of the tangent lines or the instantaneous rate of change, which is what derivative means, it would be dy over dx equals cosine 4x squared plus 1, and then on the end would be 8x. Because what is the derivative of 4x squared plus 1? 8x. Then probably, so just you'll know, the 8x could be written in front. It's not the cosine of all of that, it's just the cosine of this part. Put that in parentheses. You lazy guys that will not write parentheses are going to have a bad day, because if you do not write the parentheses, you will think it's 8x times all of that. Okay? It's not. It's not 8x times this. It's 8x times the entire expression. Is that all right? It is only the cosine of this part right here. I'm trying to help you avoid trap. Now, if I solve this, notice how you have x squared in front of the sine x. See how you have the x squared in front of the sine x? I'm going to put a little dot in there to help you out. That's multiplication. This is going to require the product rule, because it's x squared times sine x. Product rule. Everybody see what I'm getting at? Right above there if you need to. This one's going to require you to do what? Product rule. All right? So, dy over dx, the derivative of the x squared is 2x. Write down the sine x plus x squared, and then the derivative of sine x would be cosine x times the derivative of x. What's the derivative of x? What's the derivative of x? 1. So we'll get cosine x. All right? And that's, if you know the rule, and you don't even know how the rule came about, you don't even know where the rule came from. If you know the rule, you can still find slopes of tangent lines, you can find instantaneous rates of change. If this was a position formula, this would have been a velocity formula. Fair enough? All right. Raise your hand if you're happy with this so far. Is that okay? Yeah. And you're just having to trust me the formula works. All right. Now, Let's do this. The derivative of cosine u is equal to negative sine u du. We'll work a few with that. All right. Y equals cosine pi x. And I just realized I forgot to do an example that I wanted to do at the end of the sine, but I'll show it with this one in a minute. All right. dy over dx negative sine pi x, and then times the pi. Don't forget the derivative of pi x is just pi. Pi is a what? Constant. Pi is just a number. And so you might write it like this. Like so. Notice you're having to go back and use your other rules. And I like the way, I see some of you writing out the notation in front like you're supposed to. If you do not write out the dy's over the dx's and all that, you will have scribbling stuff that doesn't help you. All right, I need to mention this one because I didn't with the sign. Okay, notice there's just a constant in front. You don't have to use the product rule. You can, but you don't have to. You have to use the product rule if it's a variable expression times a variable expression. But since that's just a constant in front, you do not have to use the product rule. Just simply write down the 5 and then use your rule. Derivative of that would be what? Negative cosine 2x times 2. So negative 10 cosine 2x. Should be sine. Ooh, man. And I'm on film doing that. Can't believe it. I messed up that bad on film. You know, they got, well, it's not even film anymore. It's little digital bits running around in there. All right. Thank you, sir. Who said that? Brave man corrected me, but I was proud of you for doing it. You know, I found this when I was cleaning out my desk, and one of my former students gave me this. I'm going to put it up there so they can see it right there. And he is now a PhD chemist of some sort, and it says, crush the weak. Pen set, you know, pens don't work anymore, but at least it says crush the weak on it. Kind of just makes you feel good. When you go off to college, I want you to be able to make the students there in the other classes look bad. I want you to know it. And I want you to know it well. All right. Now, let's do this one. Y equals sine x times cosine x. And I'm going to put a little dot there to let us know that this is a what? Product rule. Is that okay? Is that cool? So, make sure we're happy. Ready. Don't want to go too fast, but don't want you to go to sleep. All right. We're going to take the derivative of the sine x, which is what? Cosine x. Fair enough? So we're going to be cosine x, plus, then we're going to write down the sine x. Is that all right? And we're going to take the derivative of the cosine x. And the derivative of cosine x is going to be what? Negative sine x. And we'll put it times negative sine x. And we're going to simplify that. Is that okay? We're going to simplify that. cosine squared x minus sine squared x. Fair enough? Pretty cool. That is not how the answer will look in the back of the book. How many of you have a unit circle sheet from last year? Right? How many of you are going to find your unit circle sheet from last year? How many know that you're going to need it? Because to be honest, that's cosine 2x. That's how it would look in the back of the book. It's trig identity. All right? Trig identity, and that equals cosine 2x. And that's what's going to make it difficult for you sometimes. Now, is this good? Yeah. If I ask you what is the slope at pi over 2, put pi over 2 in there, work it out, find the slope. Okay? If I ask you what's the slope of pi over 3, put it in there, work it out. But it might be easier to put it in where? Right there, right? Okay? So it's one of those things where you're going to need that sheet with your trig identities to help you get through and start learning the trig. This will force you to learn the trig steps. Honestly, if I took that, I'm going to work this a different way. Everybody happy so far? And young lady, did you know that was trig identity from last year? Yeah, you saw that one last year, right? Okay. It's all right if you didn't. You can tell me the truth. Here's what you would see somebody that was really trying to make life easy. I'm going to put a 2 here times 1/2. Does that change the value of it? No. But then I can write y equals 1/2 sine 2x. Because 2 sine x cosine x is a trig identity too. It is what? Sine what? 2x. I just avoid having to use the product rule. Get what I'm getting at there? Sometimes if you know enough trig to rewrite these, you can avoid, long drawn out problems. Now, you don't have to use the product rule because that's a constant, right? So 1/2 derivative of sine 2x is going to be cosine 2x times another 1, 2. Students always forget. They'll write this down. They forget to put the derivative of it out here on the end. That's what you, and then you get the same thing we were talking about a second ago. There you go. All right. So, get your sheets. If you weren't in my class last year, or if you don't have it, get somebody to get you one. Make copies of it. You can use my copier, but you're going to need your unit circle. All right. Now, here we go. Let's go ahead and get this one out of the way. The derivative of tangent u. Is equal to secant squared u du. Well, the good news is, if you know the formula, you can take the derivative of tangent different parts. Let's see. Y equals tangent 3x. Y prime, that means the same thing as dy over dx. How many of y'all knew that? Y prime is the same thing as dy over what? Dx. Is that all right? I don't like using that shorthand, and I'm not going to. I'm not going to get lazy yet. Okay, all right, secant squared 3x. And then I take the derivative of 3x and I put a what out there? 3. Okay. Everybody happy with that? Good. Right. Well, let's do this. Let's go y equals sine x over cosine x. That would be the quotient rule, wouldn't it? Everybody agree that would be the quotient rule? Somebody says, no, Mr. Evans, it's y equals tangent x, and I can just use this rule. You're absolutely right. You really don't need to use the quotient rule for that, because that is what? Tangent x. And the derivative of tangent x would be what? Secant squared x. Right? But let's see what would happen if you did use the quotient rule. Pretend you didn't see it was tangent x. Let's use the quotient rule. A little practice here. You square the denominator. Is that all right? Then you write the denominator down. All right. Then you take the derivative of the numerator. And what's the derivative of sine x? Cosine x. Minus, you write the numerator down. Then you take the derivative of the denominator. And what's the derivative of cosine x? It is what? Negative sine x. And so then you get cosine squared x plus sine squared x over cosine squared x. And you have a magical moment there. Somebody tell me what's the magical moment.
Sine squared.
Keep telling, talking. That's one. That's the mother identity right there. Cosine squared x plus sine squared x equals 1. Mother identity. That's 1 over cosine squared x. And then you realize that 1 over cosine is what? Secant. So what I did here is I actually proved this one works too. This is the proof for this one. You can't prove these two because these would require limits. All right? But this one you can prove. These two would require limits. All right. Well, let's keep going. The derivative of secant u is equal to secant u tangent u du. So, you had y equals secant pi x squared. Dy over dx would equal secant pi x squared tangent pi x squared. And then don't forget 2 pi x out there on the end. And that's the derivative. You might have just hit the point where you go, oh, I'm going to have to memorize 6 formulas, but they're not hard to use. Is that fair enough? Is that a fair thought? All right. Derivative of cosecant u is negative cosecant u cotangent u du. Don't use anyone else's rule. These work. And then the derivative of cotangent u is negative cosecant squared u du. And those are your 4 trig derivatives. All pretty and happy for you. Now, Mr. Evans, here we go. Gotta use your brain here. look out. Find some examples for you. Trig derivative rules. You can't see it yet because it doesn't have a video with it yet. But I think, oh yeah, there's what I want. All right. Let's look at number 12. Let's see what we can do with number 12. This is light hole number 12. It's section 3.5. Light hole 3.5, number 12. And I'll write it right over here. Light hole 3.5, number 12. F of x equals x squared sine x plus 2x cosine x. All right. Don't try to get, you know, you can always look and see if there's a trig function hiding in there. There's not. All right. You might want to try to factor something out. I wouldn't. Here's what I want you to see. Does everyone see that's going to be a product rule there, right? Is everyone okay? That's going to be a product rule. Plus, and then you're going to have another what? Product rule. So this thing's going to go all the way across the board. But really, if you just saw this part by itself, it wouldn't be too bad. And if you just saw this part by itself, it wouldn't be too bad. So we're going to work this one out, and we'll put a plus sign, and then we'll do what? Work that one out. Now, do not take the derivatives of just parts of it. You take the derivative of the whole line at one time. So here we go. Let's see if we can do this. dy over dx equals. Take the derivative of the x squared, 2x. Write down sine x. Plus, write down the x squared. Take the derivative of sine x, and what is the derivative of sine x? Just what? Cosine x. Good? Now, we'll double check that. Took the derivative of the first, wrote the second one down, plus first derivative of the second. So that took care of this one. Is everybody okay with that? And if you need to, make your little line and show this is all from that very first one. Happy? Everybody happy? Thumbs up. Good? Okay? Plus, take the derivative of 2x is just what? 2. Write down your cosine x plus 2x, and then what's the derivative of cosine x is what? Negative sine x. And then you start trying to simplify it. And we're going to talk about simplification. I hope somebody already sees that you have 2x sine x here, and you have negative 2x sine x there, don't you? See? Is that okay? I did something wrong. I jumped to simplifying it before I made sure everyone was happy with the slope of the tangent line formula. Everybody happy with the slope of the tangent line formula? Is that okay? If you are not happy, please let me know, because I am a kind, caring man today. All right. So really we're going to end up with dy over dx equals x squared cosine x plus 2 cosine x. All right. Okay. Pick out one of these. Which one would you like to see worked here? Anyone? 18 down this side over here. Anything in this area? What would you like to see worked? Pick one. 30. 30. All right. And we're going to treat y, we're taking the derivative with respect to y here. So we're going to say the derivative of y is just 1. Okay? Derivative of y is going to be 1 there. It says take the derivative with respect to what? Y. All right. Here we go. Number 30. Is everybody all right that it's going to be a big old quotient rule probably? Probably the best way to work it, big quotient rule. All right. Derivative with respect to y of tangent y plus 1 over tangent y minus 1. All right. Use the quotient rule. Use the quotient rule. Tangent y minus 1 squared. Then write what? Tangent y minus 1. There's your denominator. Take the derivative of the numerator. Well, the derivative of plus 1 is just 0, but we've got to deal with the tangent y. And what is the derivative of tangent y going to be? Secant squared y times the derivative of y, which is going to be what? 1. All right? So, secant squared y. Minus, write down the numerator. Take the derivative of the denominator, and the derivative of the denominator right here is just going to be what? Secant squared y. Now, I don't know whether to distribute this out, secant squared y, and then collect like terms, or what could I actually do to both these? I could take secant squared out y out of this one, and I could factor secant squared y out of what? That one, couldn't I? You do it either way, you still get to the same place. All right? I want to take the secant squared y out of both of them just to show you what it would look like. Right. We'll take secant squared y out of this part, and that's just going to leave what? Tangent y minus 1. And I'm going to leave that in parentheses just so it looks pretty. And then I'm going to take secant squared y out of this part, which is going to leave what? Tangent y plus 1. And then I'm just going to write down my denominator. Usually, the denominator just needs to stay there. All right, and then what happens? Oh, look what happens here. Tangent y minus tangent y, right? And then negative 1 minus 1. So all of this in brackets is just going to turn out to equal how much? Negative 2 times that. Now, so negative 2 secant squared y over the denominator. Now, if you look in the back of the book, you start trying to match answers. Do everybody realize you can move this and make it cosine squared y here? Is everyone okay? You can make that cosine squared y right there, right? Okay. You need to write some trig. Use the quotient rule. All right. Now, move. Somebody tell me what I just do wrong here. What is all of that? I put that. Okay. Now, here's some more, right here in the middle. Oh, this says find f prime at the a value. So what are you going to do? You're going to take the derivative, and then you're going to substitute in this a value, and that will tell you what the slope is at that value. In order to do that, what are you going to have to know? You have to know your what? Unit circle. Okay? Sorry, I shouldn't be yelling and screaming right over top of you. You got to know your unit circle. Let's do number 30. Let's do 39. Let's do 39. We're going to write the equation of the tangent line. We're going to do more than what they're asking. They're asking you just to find the slope. We're going to write the equation of the tangent line for number, I can't give y'all an odd one. I can't do an odd one in class. Yeah, I can. We'll do an odd one. 39. Lots of examples for children. Okay. Y equals